Welcome back, friends, to your own channel Balvigyan Bharti with Avilash Sarkar. We have recently completed the profit and loss and few problem solving sessions. There we have discussed several different kind of problems. Now the subject we have chosen to proceed is a very easy subject, and I might have come across the subject earlier also, but not to that extent that has to be. So I again bringing this to you. That is the subject quadratic equation. I have discussed few of the parts while discussing the equations as a whole, but this is a specific case that is very useful not only in mathematics, few problem solving in other part, that is mensuration and different kind of physics related subjects. Those may require this quadratic equation concepts. So let me start with a term quadratic expression. Now, to understand the equation, we have to understand the expression first. So, what is an expression? Expression is the combination of variables and constant. Those might related to the any form to each other, but that expression will not concluding any result. That means if I say ax plus b, and this is an expression. If I say this is existing in universe or in reality, but this will not conclude anything, but this consisted of constant and x being a variable. They are related like that. And if it is not concluding any result, that means this expression is valid for any value of this variable and the fixed value of a and b. Okay, this has an infinite value that could possible, that will give the expression a real form. So this is an expression. So expression doesn't not conclude any result. Okay, so this could be of any order. What is order? I've said the variable, the power which is carrying, the power it is there on its head is the order. So expression can be of any order. This, for example, it is a one order, that means linear expression. Somewhere it could be something, if I write it like that, the order is 2, so this is become second degree or second order of expression, like that. Now, as I said, expression does not conclude any result. But if in case this expression conclude and the result is equal to 0 for some value of the variable, then that case would relate as an equation. That means if I can say for any value of x this becomes 0, that means if I put the value of x is being x1, that will conclude this result. Or some expression like that, if it is conclude for any value of x or some value of x, not only x, there may be, let's say, other values also which will conclude this equal to 0, then this form is called the equation. That means A expression, if it is concluded to 0 for any value of the variable, that is called an equation. Understood? So, specifically, if I turned a quadratic expression into a form so that for few particular values of variable means variable the expression become the value of expression, the value of the expression become 0, then such relation is an equation. So if it is quadratic expression, then the equation will be called quadratic equation. Simply, if it is linear, then linear equation. If it is polynomial, polynomial equation. But specifically, if quadratic expression for any few values of the variable become 0, then that is called the quadratic equation. Okay, understood the definition? Now, that means if I say any expression, let's say f of x, that means there is a function which is of x, that means I will only write the variable for which the function is in a state of variation, means there is nothing which will change the value other than the variable only, then the function is a function of that variable, we could say. So if fx represents expression, then f of x equal to 0 will represent equation. Okay, so this is a generic form of an equation. I will not write the specific case. There may be possibility for f of x1 it is 0, for f of x2 it is 0, f of f3 x3 is equal to 0. There may be several values for which the function fx could be 0. So in general, all such function can be represented as f of x is equal to 0, where we can write x1, x2, x3 all are the solution of that equation. Those are in other terms also called the roots or zeros of the equation. So these are the term generally called roots or zeros of the equation. Okay, so these two terms can be used for any equation of any degree, of any order. Okay, so these are the general terms. So coming back to the quadratic equation, we can assume a generic quadratic equation in the form of ax square plus bx plus c is equal to 0. Okay, so this is a generic quadratic equation, so we can write it like that. Now you can see this has a order of the variable. Now x, the first declaration, x is a variable. How will you identify a quadratic equation? If this all things matches. Condition 1, x is a variable. Condition 2, that can be observed immediately, a, b, c are constant. That means it would be a numerical value always. Okay. Third, a cannot be 0. A will never be 0, because logically if a is equal to 0, then coefficient of x square is 0. That means this term altogether will be 0. So there is no existence of the order 2. So this will not be remain as a quadratic, because for quadratic equation the order has to be maximum 2. So this is the maximum order of the variable. So I will write it in the bracket, x is 2. It would not cross the maximum variable 2, neither it will be less than 2. So the maximum order of the variable is equal to is 2, or the order, you can say. Don't say maximum, because that will be confusing. Then the order, basically the order of the variable x is 2. So that will define the order, because when you say the order is 2, so that means it's not that the only order 2 will be there. There may be possibility order 1 also there, because that is not overcoming the maximum, overcoming the number 2. Okay. So if I write it maximum order, so there is a possibilities that we can confuse whether the order 1 also will be there or not. So if I say the maximum order is 2, so there is always a possibility to ask what is the minimum value. If I say the maximum is 2, what is the minimum value? So there will be there is always a ask for a range, because when you define something maximum, there is always a to define the limit has to be a minimum one, but there is nothing minimum. Because quadratic equation only and only true when the order is 2, not less than 2. So I cannot write here it is maximum order. It is the order which will carry 2, and there is no harm if the less values also there, less orders also combined in the equation. So this is the perfect way of describing. Maximum, it will be confusing. Okay. So the next. Next is what? X, the you can say it should not be written up, but for clarity I will write the order 1 or 0 may or may not arrive in the equation. So it's not that if I don't find x order 1 or x order 0, that means a constant. Even if it is not there, still this part only can said to be a quadratic equation. Okay. So this part is must, this part is not must. It will be a associate part. Okay. So from that, the order 1 or 0 may or may not arrive in the equation. Okay. So fifth is this one. if I say sixth, this is just the extension of that. The maximum, here I am using maximum root or the zeros possible is 2. Now here limit can come. Why I am saying maximum root or zeros is possible 2? Because in a quadratic equation the order is 2, so there is only possibilities for x. The value of x could be maximum 2, for which this expression can be 0, but there is a possibilities that I only get a single root also. Okay, why I am saying a single root is also possible? Because the both root can be of equal, say for example, if I find some equation x square is equal to a square, so still it is a quadratic equation. But the value of x is equal to, can be a and a both. Now from this equation you can say it can be a plus a minus a. Yeah, that can be possible. But even if I get both a, that is also not wrong. Both the thing is equal to a will give you this expression. Both the things is a, one is plus a, one is minus a, also will give you the same result. Why I am saying x minus a whole square, so that means x minus a into x minus a is equal to 0. That will give you x is equal to a. This can be something like that also. 0. So this is the case, this one. So this can be possible if plus a minus a. Now x is equal to a possible for this equation. So both will be equal. For this case, x is equal to plus a and minus a possible. So I am not saying that both can be equal is not possible. Both can be equal is equal to possible when your equation is like that, x minus a whole square is equal to 0. This is still an quadratic equation. Okay, you cannot say that no, you can turn into x is equal to a is equal to 0, because if you take the square root, that is the case you will take the square root, as because both the values are same. But seeing it, if I expand it, it is in the form of a quadratic equation. Is the highest order is 2, the lowest order is 0, because that is in the form of ax square plus bx plus c type. So this is a generic equation. So this also can be a quadratic equation. Okay, so what I mean to say, the maximum number of equation of the root is possible too. It would never cross more than 2. You will not get any 3 solution for a quadratic equation. But the maximum possible 2, but the lowest can possible be 1 also. Okay, so this is the case. Now some more associate, you can say the theories or the concept will come when I'll discuss in details the quadratic equation. Okay, so these are the main you can say the properties, or the you can say the features of an quadratic equation. Okay, so I might have shown you how to build a quadratic equation and their roots. So as because I will show you again how I brought that roots, the formula of roots for a generic quadratic equation. This is a generic quadratic equation. If you have remember, I have put it in the form so that I can get I can separate x with other constant, there x I will get in means two values of x can be detected. So let me take you in the same way. So I will divide it in with a the full term. So there is the will be the same 0 will remain because 0 by a is nothing but 0. So now x square plus, please see how I am doing, because this is the another method when I will discuss how to solve the roots or the zeros of a quadratic equation. This, if you follow this process, you will get a process by which you can also solve a real problem. Whenever you will find some quadratic equation to find their roots, you can use this procedure. This is called the method of describing it in a square. Okay, this is a squaring method, you can say. In your term also you can say something else, but this is the method of doing or you can say calculating squares, calculating roots by square method. So the same process has to follow. So x square, I am writing it in the this term, I am writing it 2 into x because x is there. As because I bought 2, so I will put this term, I will write this term in this form. So that there 2 will be cancelled out, and ultimately see xb by a will remain. So the other thing, now why I am saying doing this is a square. I am just putting it in the same way that your formula may arrive, 2a into b. So this is a, this whole term is b, that means I need something b square. So b square I am bringing, this is not there in the picture. As because I bought it, to balance the equation I have to take it out, the same term, so that there is nothing change in the left hand side, and the remaining term is, it is already there. So totally the expression is arranged by bringing something and deducting something, but as a whole the same thing will remain same. This, okay. This is only the representation that is needed to solve it or bring it in the square form. So now this is x plus b by 2a whole square, this whole term a square plus 2ab plus b square, and the remaining term, this one I am putting it in the right hand side. So this will change its signature. Okay, now let me solve this way. So the LCM will be 4a square. So this will remain as b square minus a, if I divide it, so it will remain 4a into c. Okay, so this is equal to something. So if I if I do the square root of both sides, so this will now one thing you might know, whenever I do some square root of some squares, the other side there will be of value possibilities, both plus and minus is possible, because if I do square of a square, that I will get a, minus a square also I will get a, because minus square means minus into minus. So you know the 2 minus when it is multiplied become plus 1, and plus is obviously plus. So this is the case whenever you do the square root of a square, if it is a real number, then you have to take plus minus sign outside. So this will come as plus minus, this will be under square root because this is not a perfect square, that you can say, unless I can get something value that will turn it to a perfect square, that is possible. Now if I do square root of this denominator, this will be something like that. Okay, so let me bring this term also in the left hand side, that will be b. Now for this 2a will be the LCM, so I will keep 2a the denominator, and this sign I will stick it to the b. because this is only carry b that side, so minus b I can keep. This plus minus will remain before this term. Okay, so this, see, there are two sign is coming, plus and minus. What does it signifies? It signifies if I take plus, I will get one value of x. If I take minus, I will get another value of x. So this can be represented as two roots of the this quadratic equation, x1 1, where if I take plus, x2 if I take minus. I am representing, it is not that x1 x2 you have to take all as the main thing is that you will get two different values. Okay. So this is the process by which, by turning it to a square, you will get the square root of this quadratic equation. Okay, and this part, this is a specific part, this is called discriminant. This term is called discriminant. This has a specific role to distinguish the characteristic of these roots that I will discuss in the later class. So this term is called the discriminant of the roots of the quadratic equation. Okay. That's it. I will come back to the next class while I will discuss on this, and for specific values of this, as because this is under root, for specific values, how that roots will behave, or how the roots will be distinguished. There could be a different characteristic of the roots depending on this discriminant. Okay, so that's it. Thank you. Good night.